All right, so this pedigree was kind of interesting because they give you two different traits that you're tracking. And I'm not doing the whole problem, but I want to focus on one of the questions they asked was they asked in generation 4, so they gave you this notation, IV-3, which is saying in generation 4, the third position of generation 4, what is the probability? So probability that they have probability of the disorder. So what's the probability that this individual has this genetic disorder? It's like, what? And we're looking at, when I say disorder, we're talking about disorder A or condition A. So this one. All right, well, if you're looking up here, looking at these, so tracing back, you'd have to be looking at these two individuals, this mating pair, that mating pair, and then, but how would we come up with the probabilities? Well, looking here, you notice how the parents don't have it, and this offspring 6 here does have it. So what does that tell you about the genetics, the genotype that this individual would have to have that disorder? Or in other words, what kind of disorder it is, dominant or recessive? Recessive. Be recessive, and how would you know that? Yeah, so recessive disorders, so that would mean that this individual is 2 of the recessive alleles. The only way that can happen, the only way for 2 parents who don't have the disorder to have an offspring that does is if it's a recessive disorder, okay? So if we kind of do the Punnett square here, it would look something like this. Okay, so there was a 1/4 chance that offspring, that one of these offspring would have that recessive disorder. So basically what we're asking is, what is the probability that this offspring down here is little a? That's essentially our question. And, well, let's kind of figure this out here. So in order for this offspring to have little a, what would the genotypes need to be for these 2 parents, for the parents of that individual? So let's kind of work backwards. Yeah, go through. Yeah, they'd have to be just like them, right? They would have to be heterozygous, big A, little a. Now, again, I'm not saying they are. We're going to have to calculate probabilities, but they would have to be for that ever to happen. Okay? So we're going to have to do some probabilities here. And then going back, if these parents don't have it, what would that mean the genotypes need to be of these parents here? Kind of working backwards. So if they don't have it, but then they have an individual, an offspring, that does carry the recessive allele, what would that tell you about their genotypes? Go for it, Kabir. Yeah.
At least one of them is heterozygous.
So yeah, one of these parents has got to be a carrier for it. Okay. Now here, number 4, we're assuming, and 8. I think they tell you this in the problem that you can assume that they don't carry the recessive allele. There wouldn't be any other way you could solve the problem unless we're assuming that they are not carriers of that recessive allele. Now, if you look over here, what would be another piece of evidence you could use to support that this female here is big A? That would be a safe assumption, a safe enough assumption for us to do this calculation. Well, notice how nobody over here has the condition, so that's why you can kind of assume that there must be no recessive alleles for that condition over here. That's the assumption you have to make here. Okay? So then this recessive allele had to come from somewhere, so it has to come from the male, both of the males here. You okay with that? All right. Now then, we have the genotypes we need. So what we need to figure out is, what is the probability that you would be big A, little a, or big A, little a here for either one of those? So using our Punnett score, what would be the probability that 2, 5, this male will be big A, little a? 50%? No. You're like, like your entire world's, cause yeah. And truthfully, I thought the same thing too when I first did these. Because you're like, well, I'm a blocker. I got 4 possible options here, and 2 of them are big A, little a. So 2 fourths, which is 1/2. But it's actually not what's going on here. It's just tricky. It's real tricky. What's going on? Why is it not 1/2? Tice?
Well, we know that it doesn't have this condition, so it can't be little a, so it's 2/3.
Exactly. We know, by the benefit of hindsight, we know they don't have that condition, so you can remove one of your possible offspring. So it isn't 2 out of 4 possible offspring, it's 2 out of 3 possible offspring. Very, very tricky. So then what that means is there'd be a 2/3 chance that this male is heterozygous. This would be the same odds. He would be 2/3.
Oh, that's what the problem is.
And then, all right, so then let's go down to our 3rd generation. So then we got to figure out what are the probabilities that these 2 parents here could be heterozygous. And to figure that out, you would need to do a Punnett square. We would make another Punnett square. We're doing big A crossed by big A, little a. So let's draw that up here. Do it right here. So one parent's big A, the other one's big A, little a. So these are our possible offspring. So what would the odds be then that you could get that they would get an offspring that is big A, little a? What was it?
50%.
Yeah, this one would be 50%. Okay, so now this one, because half of these ones, because here's the deal, you can't rule out, you can't cross off any of the ones like this. If you're like, well, why are we now using 4 possible offspring? Like, why is it now 2 out of 4, but here we had 3 possible? Because you can't cross off any of those possible offspring. You can't use the benefit of hindsight to do that. So both of these, the female and the male, they both would have a 50% chance of getting the heterozygous genotype. Now that we're going to do one more Punnett square, well, really we don't, because we already made this Punnett square here. So then using this Punnett square, what would be the probability they'd have this offspring that would be little a, assuming that they are big A, little a? That would be 1/4, okay? So then, to answer our question, the probability that this individual would have the disorder would be, you use the multiplicative property, right? It's like you're essentially saying, what are the odds that I get, I get heads, you got to multiply all these together, like, because these are individual events. So 2/3 chance that you would get big A, little a, another 2/3 chance that he's big A, little a. So multiply those together, multiply by 1/2, multiply by 1/2, multiply by 1/4. They're all individual events. That would give you the probability that individual would have the disorder. Is there questions about that? If that makes sense, I mean, that's about as hard as they're gonna get. That's pretty elaborate. But the key is you gotta this idea that you can eliminate one of the possible offspring.
I understand.
Okay.